inverse of a function? That would be graphing a log. If I just gave you, let's start with inverses. Inverses of exponentials and logs. No, this is still 6.4. We're spending multiple days on this. This is hopefully the end of 6.4. So still 6.4. So if I gave you, example, do y equals log base 7 of x, let's go back. This is a function. So f of x equals, sorry Lily, I see you racing hard, log base 7 of x plus 5. And I said find the inverse. At the beginning of 6.4, we talked about inverses. What do I have to do to find the inverse? What's my first step? I will in a second. Yes, there's some things we have to do before we can solve and do that. Look back in your notes. 5.6 talked about inverses, and at the top of this one, we also talked about inverses. All about inverses. How do I find the inverse? Like if I give you y equals 2x plus 5, how do I find the inverse? Yep. Yes. So I'm switching x and y, right? Okay, let's do the same thing here. I don't have a y yet. What is my y here? Yep, f of x. So that's y equals log 7x plus 5. Sorry, that's my phone. So we have to rewrite with y equals. And then the next step, switch my x and switch my y. So x equals log base 7 of y plus 5. We need to do that each time. So switch x and y. Hawaii, what's my next step? Yeah. Solve for y. Which is, Mock already said it. What do we have to do? Yes. Switch it. Then But I get y all by itself. So what happened when I switched it? What is my exponential function? Okay, y plus 5. And then I gotta get y all by itself. So what do I have to do, Angel? What was it? Yep. So I get y equals 7x minus 5. How do I denote that this is an inverse? If it was f of x, the inverse of it is f inverse of f of x. Now, how do I verify that my inverse is truly an inverse? What did we all love to do in 5.5 with the fog and the other way? Composition. We gotta do composition to verify. So next, verify by composition. So I have to do just like composition. Remember that's f of g of x, or g of f of x, we call. Okay, I'm gonna scooch this down a little bit. So we have to do f of the inverse of f of x. It has to equal x, but to be its inverse. We also have to go the other way. Also has to equal x. If true, then f inverse of x is the inverse. How did we like composition? Did we enjoy doing it? Do we remember how to do it? Thumbs up if you do. Thumbs down if you don't remember. Okay, we're gonna do this one together. Which way do you want to go first? First or second? Okay, Mark wants to do first. So, I'm gonna write my functions again. F of x was the log 7 of x plus 5, and my inverse was 7 to the x minus 5. So those are my two functions. Mark wants to do the first one. So we have f of f inverse of x. Does that equal x? That is the question. So I'm going to start with my inverse. We have f of my inverse function. Now, wherever I see an x in f of x, I'm going to put this bit in. Okay? So I do log base 7. What would I put inside? Minus 5, yep. And I got my plus 5 over there, plus 5. Any questions about how we got to this point? Okay. Take a second. Yeah, Michael. Because that's my original function. Yeah. So I'm just rewriting it so we had it down low because I had to scooch up. Anything we can simplify right now? Yep. That simplifies down to 7 to the x. Have we seen this before? What? Oh, okay. We have? What is this equal? No. So my bases are the same. These are two inverse functions with the bases that are the same. So this is very similar to this. Index of 2, x squared. What is this equal to? X. My exponent and my index are the same. Over here, my base and my base are the same. So what do you think this is going to equal? just x. So these bits cancel each other out because they're inverses. So I'm left with just x. That was the easy one. Okay? Do you have any questions at that point? Need same base. Then you can't do it. Yep. And a normal problem, if you take like the log of both sides, you're gonna set it to whatever base you want. In this problem, we can't set it to a certain base. Yeah. We're gonna talk more about that probably Thursday. Okay, so we still gotta do number 2, which is f inverse of f of x. Does it equal x? That's the question. I want you to set this one up with composition. Does it really equal x? We don't know yet. We're trying to decide that. Okay. What am I putting in my parenthesis right now? Guys, can we quiet down? Angel's trying to talk. Look, Angel, what did he say? Log base 7 of x plus 5. So that's what we're putting inside. We know f of x already. This is our f of x function. We're just plugging in. Now, wherever you see an x in the inverse function, you're going to plug this in. So where's my x in the inverse function? The exponent, yep. So 7 log base 7 of x plus 5 minus 5. Oh, that's, yeah, I know, Michael. Now, we're doing the same idea as before. These are two inverse functions. Exponential is the inverse of what? Yes, of a log. If you don't know that, write it down for the 3rd time in your notes. A log function is the inverse of an exponential function. So like x squared, the inverse of that is a square root. So they undo each other. Inverse of a what? An exponential function. You wrote it on the top of 6.3 and 6.4. The inverse function of a log function is an exponential function. The inverse of an exponential function is a log function. Yes. These are inverses of each other. So that means Okay, in words, if I graph a function, don't write this down. This is an exponential function, right? Yep. An inverse is over y equals x. So my log function looks like that. They're inverses of each other. We are flipping them over y equals x. They cancel each other out. Yeah. You know this. Ronaldo it is. What is the inverse of sine? Geometry. Is sine. So they cancel each other out, right? They just cancel each other out. You're left with the x. Okay, let's go back to our function. This is very... What's up, Michael? Yes. Yes, yes, yes. Yep. So this is called, I'm going to write it. Put this, it's called exponentially, no, it's exponentializing, but there's also exponentiate. We're going to do that one, exponentiate. I'm going to spell it right, hopefully. Exponentiate base 7. So we're raising it. Our bases are the same. So exponentiate a log with the same base. So need same base. Then they cancel out because they are inverse functions. And Michael, what am I left with? So we are left with the argument. Okay. Well, exponentializing. So when we have a log and then we make it a power, and we have the same base, these are inverses of each other, exponentials and logs. So they're going to cancel each other out. We're going to bring down the x plus 5, and we're just left with the argument. Yes. Liam, how are you doing with it? Do you have any questions? No? Okay. So I'm left just with my x plus 5. And I still have my negative 5. Yep, so just x. So yes, it's inverse. Yep. No, still need the same base. We need the same base every single time. You cannot change it. If these are not both 7, these are not both 7, you can't do it. Yes. You need to have the same base. And it's going to equal whatever argument is. So up here was x. If this was x plus 10. This would be x plus 10. So it's going to equal the argument. So this one, bases are the same. It's going to equal whatever the argument is. So this one, bases are the same. Whatever the argument is, that's what we have left. This is the base. This is the base. This 7 is low. Yeah, fine. Yes. Honestly, I didn't put it in because we weren't going to do homework about it, so no. But the graphing will be, and this will be on your test. Of this lesson, because we worked so hard on it, yeah. What? Quiz tomorrow. What did I say, test? Yeah, no. Test is like next week. There's a lot we still have to do. Okay. Sebastian. No. It just oh, can't cut five? Yep. So it just comes down. It just comes down. If we exit it, G. So it just comes down. But then what would I be raising this to? Nothing. I would be raising this to half of this. Okay. So these are the bases are the same, so they cancel each other out. So bases are the same, left. Yeah. So this is just a check to make sure that we got our inverses correct. Okay. We're gonna do some practice problems. Not not that one. We did not get to that. Sorry, that's tomorrow. Yeah. This is what a quiz is on for tomorrow. You should know how to solve all of these right now. Okay, perfect. Then we're getting into some groups. And this is what we did in 6.3. Oh. Guys, those are... Yeah. Okay, we're going to get into groups and do this on the board. Because Jay has spent a little bit of time since we've done this. Guys, these are your groups. Okay, you're going to find the group numbers and find a board. That would be soup. Yeah, I knew it started with an S. We'll find a group. 6 is over here. 5 is over here. What's over there? Where's 5? Go to group number 7, the board of this. Who's the 7? Okay, then go to...
That's easy. 2. Logic. I don't know. It could be 7 or 2. I'm guessing 2. Because X would be like the exponent. If you put its exponential form. You get me? You pick it up what I'm putting down?
Okay. Sorry.
It would be 2. Because Lily should make
You're doing the problems inside.
Yeah.
Violence. Need that.
What the heck? Oh, pause this.
It would be 2.
Guys, scooch for the ladies. So they can pop in.
We're doing it.